good morning, you mathers, or afternoon, whenever you're watching this video, because it's available 24/7. So hopefully you're doing your math at all times during the day. So this was a challenging problem, 22. It gets challenging. It starts pretty straightforward, so let's work through it. We want to find the inverse of this function. So the first step, remember, there's like a 5-step process. Just follow the process, follow your steps. First step, f of x equals x squared plus 2x. Step 2, replace f of x with y. Step 3, interchange all the x's and y's, and make sure you don't just interchange this first one, you also have to do this one. So wherever there's x's, you rewrite them as y's. And then the y's become x's. That's what makes the problem tricky. Now you have to figure out a way to get the y by itself. This problem is hard because you have y squared and you have 2y. There's really like no simple way. How can I get y all by itself? How can I isolate y? So I really don't even know where this would come from. Divine inspiration would tell you, hey, let's just do a +1 here. Why can you do that? Well, since it's an equation, you can add 1 to one side as long as you add 1 to the other. That's why you can do that. I guess the clue is when you have a squared term plus another one of the y, that we want to factor that. And so in order to factor things, we need trinomials. We need a constant term. And so you're just kind of figuring out, well, what constant term would make it so that this would be factorable, and it'd be like a nice, clean factoring. Because you could put any number here, basically, and make it factorable. But you want something that's going to be very clean. This particular one, with a little bit of looking at that, like you could do a diamond method, that will factor to y plus 1 squared. And that was key because I want to have just something squared so that I can take the square root and then I can get rid of that and just end up with a y. So make sure you can see that how I went from y squared plus 2y plus 1 is really y plus 1 squared. That was the key to this whole problem. So then other side is x plus 1. So now take the square root of this side, and I just do the same thing to this side. And so now I'll get y plus 1 equals the square root of x plus 1. Now I can get y by itself because now I can just subtract 1 from both sides. Now you're not going to go inside the square root. You're going to have it outside. So I just brought the 1 over. So now you have your final answer. Y is equal to the square root of x plus 1 minus 1. And if you want to be all technical, then you could rewrite it finally as the inverse of x is equal to the square root of x plus 1 minus 1. I think I did that right. Now the last part of the problem is what is the domain of this new function, this inverse? And if you remember, that's the final step. The domain is the range of the original function. So you do have to go back to the original function, which is x squared plus 2x, figure out the range. There's also a little restriction. We're saying only look at it when x is greater than or equal to -1. So I'm going to write that over here again. Y Now there's a couple ways to do this. As you get better and you do more and more of these problems, eventually you're going to come to a point when you see x squared plus 1 in your mind, you're immediately going to know, oh, that's a parabola. And then you're going to have your little tricks and you'll be able to graph that really quickly. And then from the graph you'll know the range, because the graph, that is the range, whatever the graph looks like. If you're not quite there yet, I'm still getting there myself. I'm going to just go a little old school, brute force, make a little table, x, y, and then I'm just starting to like pick a few points, trying to find like special points where like the graph is you know, at either its bottom or its top, and so you can kind of figure out what is this going to look like, what's the range. Since there's a restriction, x has to be greater than or equal to -1, that's probably a special point, -1. So I'm going to start x -1. What's y? -1 squared is going to be, oh, this isn't x, this, I wrote that wrong. This is the original function was x squared plus 2x. Sorry about that. So when x is negative 1, that's going to be 1 plus negative 2. So y is negative 1. So if I were to graph that, when x is negative 1, then the y is also negative 1. So that's part of my range. Now what's going to happen? Now x can only be greater than negative 1, so I'm not going to even worry about anything else. So I'm going to bring x to 0. When x is 0, y is 0. 0 plus 2 times 0. So that's going to be 0, 0 right here. Then when x is 1, it's going to be 2 times 1 plus 1, so it's going to be 3. And you can see what's going to happen here. Pretty quickly it's going to start to blow up because of that exponent. So when x is 2, it's going to be 4 plus 4 more, it's going to be 8. So 1, it's 3, 2, it's 8. And now you start to see, boom, it's like exponential growth going way up. If you think about it, what we're kind of seeing is 1/2 of a parabola, just half of it. So my range of the original function is y is greater than or equal to negative 1. Just like x. And then y just blows up from there. So that becomes the domain of the new function. So over here the domain is x is greater than or equal to negative 1. So there you have it. That's 22. That was a tough one. I'll do one more problem for you, but I'll pause and make a new video. So namaste.